Welcome to Global Information Security Society for Professionals of Pakistan.
So today, I guess we completed last time domain first of CCSP. So today we're gonna be going with domain 2, which is cloud data security. So this domain is going to talk about how do you secure data in the cloud and what is the data lifecycle and where the data resides, how the data traverse, where the data gets stored, what are the different types of storage in the cloud, and what security measures that you can take to protect your data. So this whole domain is about data in the cloud. If you are familiar with on-prem data security, the concepts are pretty much similar, but we're gonna talk about data security in the context of cloud. And before we go further, I just want to remind you that last time we talked about cloud services, service model, cloud deployment model. So all of those things and share security model, all of those things that we studied in the last domain, they have a role in this domain as well, but that role will be in the context of data and security around that data in the cloud. All right. So last time I got a few questions in the chat that I did not introduce myself properly. So this is my introduction. Who am I? So it will be available after the recording, and you can go ahead and read it. I can be reached at my Twitter, which is at Rehan1976, and everybody can see also my LinkedIn, which is at Rehan Bashir. All right. Okay. So let's start with cloud data concepts. So how do we create, how do we manage, how do we store data in the cloud? That's where we're going to start. So if you remember from last domain, we looked at data lifecycle in the cloud, which starts from creating the data, storing the data, using the data, sharing the data, archiving the data, and then deletion of that data. So from cloud perspective, what do we mean by creating the data in the cloud? So whether you are, using a SaaS service model, IaaS service model, PaaS service model, ultimately what you're doing is you're going to put some data in the cloud. So you can put the data in the cloud in each and every service model. Either you create new data by, entering the data into an application, or you basically import or upload an existing data into these various service models, whatever you are using, right? If you have an application, then you probably also importing your database into the cloud and connect with that application. So basically you have imported the data and you also have created a new data, a new content in the cloud. So that is the first phase in data in the cloud, which is we also call as the birth of data in the cloud. So once the data is in the cloud, then obviously you need a space to store that data. And that's where the store phase comes in for data in the cloud. So once you have to create the data, immediately after that, the create phase, you have to store the data. So data can be stored in various formats. And again, how the data is stored depends upon what type of service you are using. We will see later in the slides that, IaaS stores data in different repositories, PaaS maybe in different repositories, and SaaS have a different storage methodology of managing and storing data. So we will see those things. And it is very important to understand when it comes to cloud that how data is being stored in three major services that are in the cloud. So again, SaaS has a different method of storage of data, IaaS has different method of storage of data, and PaaS has different methods of storage of data. And we'll go through that various storage methodologies in the cloud. So the second phase in the data concept is store. Third is use in the data concept. The use is basically the use of data in the cloud, whether you're processing that data, consuming that data, which is already stored in the cloud. So use phase is generally considered as read-only and not include any modification. So use does not include modification of data, because you are just using what is already there. You are not modifying it. So you need to understand this subtle difference between use and create, right? So if you do a modification, if you do addition, deletion of data, that does not consider as use. That is considered as creation. Use is only that when you have a data and you're using it and processing it and viewing it. It's a read-only phase. So you need to understand this distinction, that there is a subtle difference between creating of data and use of data. Okay. Then we have share phase. In the share phase of data usage lifecycle, data is made available for use by others, right? So you upload the data. Now data can be used by your employees, your customers, or your partners, right? So as the data, data often traverse a variety of public and private networks location and is subjective to various unique threats along the way. So now, let me give you an example. So you have a PDF file. You create a PDF file and you upload that PDF file into the cloud application. Now you want to share that PDF file. So that's where the concept of information right management comes in when you are doing sharing, because when you're sharing the data, you are introducing a lot of threats when you're sharing the data. Data can be leaked, data can be breached. Somebody, if your proper security controls are not in place for sharing the data, somebody can steal that data, maybe credit card numbers, right? You are sharing the credit card number with multiple vendors. You have your credit card processing, you have payment gateways, you have your online store where you're buying the stuff. So your credit card information, which is the data, is being shared with multiple entities along the way during the whole processing of credit card when you're buying something online. Now, the threat of that is if somebody is sniffing the traffic, encryption is not in place, then that data can be stolen, that credit card number can be stolen. So you have to do a lot of consideration in the share phase of the data concept when it comes to cloud. After you share the data, the next phase is archiving of data. So the archiving of data is same as on-prem, where you are basically storing the data for long-term storage. So you have heard about retention policies, right? People retain their backup for a certain amount of time. In US, federal government is required by law to archive that data for at least 7 years. And the reason for that archiving is that in case an event has occurred, in case a FOIA request is Freedom of Information Act. What it means is that your data, somebody's data is stored. And if I want to later ask the US government, hey, I want to look at my data and I have a court order that, or I have based on Freedom of Information Act, I am allowed, I have my right to view my information. So that's in that case, that particular organization to which the request has been made goes into the data archives and pull that data out for which the request has been generated through a FOIA. So you have to archive the data, you have to retain the data, and it may be because of compliance reason. As I just mentioned, in US, federal government compliance requirement is 7 years. HIPAA might have some other requirements. PCI might have some other retention requirements. So you have to consider how you archive the data. So it's called the cold storage because data is sitting there. Nobody is using it. Nobody is processing it. So it's not hot, it's cold. So that's the term cold versus hot, means that data is sitting in a cold storage, just sitting there doing nothing. So, so you basically, so when you are storing the data in cold storage, you do not need fast access. You do not need high-speed storage area networks. You do not need high-speed disks, you can basically copy that data on a maybe tape drive or on a CD or whatever other slower medium that you can use to store the data. So basically you move data from a fast medium to a slow medium for a long-term storage. And it also, got into less redundant tiers, that is less expensive, or including moving data off cloud to a separate medium altogether, like backup tapes, for example. So cloud service provider, again, they can store the data into various backup tapes or whatever the slower storage medium may be, but it is offline. The next phase after archival is destroying of data. So if the data is no longer used, no longer required to be archived, or the duration of archival has expired, again, in the example of US federal government, 7 years is the data. Now, after 7 years, organization can technically destroy that data because there is no longer a requirement to store that data, to archive that data. So in that case, a data destruction can happen. And now, how do you destroy the data? There are multiple ways. If you have stored the data on backup tapes, you can run those tapes through a magnetic degaussing, or on hard disk, do magnetically degauss them and destroy the data. Or other method is you can physically destroy the medium on which the data is stored, throw it into the fire or physically destroy it through some other mechanism, right? Another way of destroying a data, which actually cloud service provider use a lot, and this from exam perspective, you need to understand this term. This term is called crypto shredding. So, or data overwriting. So what does it mean by crypto shredding? What it means is that the way to destroy the data on a medium is to encrypt the data and destroy the decryption keys. So once you encrypt the data and you destroy the decryption keys, and nobody from that point onward can decrypt the data. So that's the very effective way of destroying data in the cloud. And most of the cloud service providers provide this facility. They encrypt the data, they destroy the decryption keys, and the data is gone forever. You just cannot recover that data. And you can do it out at personal level as well. There are software out there that allows you, if you want to, destroy your data, if you are selling a computer or a laptop and you have data on there and you want to destroy it, rather than formatting it or doing anything like that, just encrypt your entire hard drive, destroy the decryption keys and format the drive, and your data is gone. Everything is done. Your data is gone forever. The last concept in a cloud data concept is data dispersion. So data dispersion is a concept of basically spreading the data across multiple zones, multiple regions in the cloud environment. As we all know, cloud is highly spread across geographical locations. So you are replicating a data throughout a distributed storage infrastructure that can span several regions, cities, even countries around the world. And what is the reason for data dispersion? The reason for data dispersion is redundancy. So for example, I have a data center in New York, a cloud data center, and my clients in East Coast are accessing data in New York. For some reason, the data in data center in New York went down. There's a connectivity issue or power issue or a natural disaster that might happen. But with the use of data dispersion idea, the data that is being accessed in New York office is also being copied or dispersed across, Midwest and also on the West Coast of the US. So now what happens is, since New York data center is available, clients will automatically be divided to a Midwest data center or West Coast data center. So data dispersion basically allows a redundancy of data and protects against loss of data if something happened to the physical infrastructure. Any questions in cloud data concepts so far? Okay, moving on. So next thing that we're going to talk about is designing and implementing cloud data security architecture. So as I mentioned that cloud uses different type of storage based on the service that you are utilizing. So storage type. So IaaS, infrastructure as a service, uses volume and object storage. So you need to remember that what type of service is using volume and object storage. So infrastructure as a service use volume and object storage. Now, what is a volume and what is an object? So if you all of, I mean, I'm sure you're all familiar with virtual machines, right? You know, VirtualBox or VMware, you install a virtual machine and then you create a drive and you attach a drive to it. So that drive is a volume storage. In your computer, you have C drive. And C drive has a structure, it has folders, it has root, it has folders, and everything underneath is organized. So that is a volume storage, right? Then we have object storage. The problem with volume storage is that it's not very scalable. Volume storage is very specific, it's very contained, it attaches, and it requires an operating system. Volume storage requires an operating system. So that is a very key point to remember, that volume storage requires an operating system. So once you, and it could be an NTFS partition or it could be FAT partition. So that's what volume storage is. But volume storage is not scalable at large scale in the cloud environment. What is scalable in cloud environment is object storage. So again, the physical aspect may be hard drives or the storage system, but the way object storage is organized is it's just a flat file object, and that object has certain properties. So object might have a metadata associated with it, telling what is stored in that object and some other attributes information. But the key point to remember about object storage is that every object in the cloud storage object has a unique identifier, which is called UUID, unique identifier. And object storage is very good aspect of storing data when it comes to data dispersion. So being a cloud user, I do not know where the file, it could be my documents, it could be my pictures, it could be anything that I upload in the cloud, they are stored in object storage. And the way in the backend cloud works is that if I want to access certain objects, transparent to me, the operating or the cloud infrastructure access that object through a unique identifier. So every object, every file that you upload in the cloud, which is stored in the object, has a unique identifier. And cloud infrastructure knows how to access certain files that I requested through that unique identifier. So that what we call is an object storage file. And you will definitely get questions on various storage types in the exam. So an object is a file storage that can be accessed directly through an API or web interface without being attached to an operating system. So as opposed to volume storage, object storage does not require an operating system. Data kept in object storage includes the object data and metadata, and can store any kind of information, including photo, videos, documents, and more. Any questions on storage types? Okay, so the next one is PaaS. So we talked about two storage types, volume and object. This is R for infrastructure as a service. Now, platform as a service, you use two different types of storage. And those are called structured and unstructured. So what is the structured data? So structured data is your database. Any RDBMS that you are familiar with, that could be MySQL, that could be Oracle, Microsoft SQL. So any data that allows you, any RDBMS that allows you to store data in rows and column format and fields, that's what we call a structured data storage. that is a highly organized, categorized, and normalized data. So if anybody of you are database person over here, you understand how we normalize data in database. And in order to access data in structured environment in RDBMS, the language that we use is called SQL or SQL, however we want to pronounce that. So structured data storage is always in RDBMS. Then we have unstructured data. And remember that, so these two methods are for pass. Unstructured data is information that cannot be easily formatted for use in rigid data structures like database. So audio files, Word document, web pages, and other form of text and multimedia fit into this type of format, storage. So unstructured is just, it is not stored in the file. So the example of unstructured is in your organization, the simplest example is you create a shared drive. And in that shared drive, you put files, you put photos, you put videos, you put any image files. That's an unstructured data. So because it is not stored in a formalized RDBMS or relational database management system, but it is spread across the organization through in the form of shares. So that's an unstructured data. So when it comes to data security, when you are saying, okay, I have an organization and I have a need that I need to secure my data, and you start doing the data identification and classification process, you have to consider both structured data as well as unstructured data when it comes to data security. So which is very important, and we'll talk about that later. Any questions between for structured and unstructured data? All right. By the way, I have a chat window open in front of me. If you have any questions, you can type the question over there. Okay, so the next service type is software as a service. Now, as we all know, and we studied, we talked about in the last presentation from the shared responsibility model. In SaaS security model, which is software as a service, think of it as Office 365, which is software as a service, or Salesforce, which is software as a service. Cloud service provider is responsible for all majority of the functions. And SaaS does not have a particular storage type as IS or PaaS, right? So we talked about IS. IS uses volume and objects. PaaS uses structured versus unstructured. But SaaS does not have, very commonly used storage methodology, but storage types, I would say. But it has two common methods of data storage. Information storage and method management. So this type of data storage involves the customer enter data into application via a web interface, and application storing and managing that data in the backend database. So SaaS can be using a structured database at the backend, right? So it could be anything. So when you are using Office 365, or when you're using anything that an application built on Salesforce, and you're entering data into that application, the front end as a user, data can be stored in the back end in a structured format. It can be stored in unstructured format, or it can be distributed and stored in an object format. So it could be anything, right? Because you are just entering data. You are not concerned with how data is stored. So that's not your worry as a customer. And the second one is content and file storage. With this type of data storage, the customer uploads data through web application, but instead of being stored in integral database, the content and files are stored in other storage mechanisms that users can access. Again, it goes back to data can be stored in as an unstructured format on shared drive. In case of maybe if you have ever used SharePoint, right? SharePoint is just showing the data as it is as it shares, but at the back end it might be a database, SQL database running that is storing that database. So the point is that with SaaS, you do not have to worry about how the data is being stored. It could be object, it could be structured, it could be unstructured. All as a customer you are looking at is the interface interacting with the file. Again, OneDrive is the example. You are uploading the data and you're sharing your file, storing your file. Backend, you don't know and you don't need to know how the data is being stored. The question is, what is the example of content and file storage? SharePoint is same as information storage. Yeah, so content could be anything. Content is file, content is picture, content is video. So content is just a general term that is being used over here. SharePoint is same as information storage. Yes, SharePoint provides you an interface, easy to use interface with a lot of logic built into it. But at the back end, data can be stored in any form. And generally, SharePoint uses a Microsoft SQL Server database at the back end to store all the data. Threats to storage types. So now we looked at, so far we looked at data, how the data, what is the data concept, and we look at various storages, how data is stored in cloud under various services. So what are the threats to storage types? Obviously, the number one threat is unauthorized access or usage. So this type of threat involves the viewing, modification, or usage of data stored in any storage type by either an external unauthorized party or malicious insider who may have credentials to the environment, but who use them in an unauthorized way. We talked about last time S3 bucket. It's a storage type. It's an object storage type. But S3 bucket, if not properly configured, and that is one of the very common things that we have seen with our clients, is that they do not implement secure configuration on these devices. They just try to use this device as default. And by using these devices with default configuration is that sometimes it so happens that default administrator or default permissions are very open. And that allows anybody who has the direct URL of these storage devices in AWS environment can access the data in an unauthorized manner and cause a data breach. And this has been a very common data breach with AWS. And the number one reason for that is misconfiguration. Second one also ties back to the first one, data leakage and exposure. Again, lack of proper configuration, lack of security review of these cloud services will lead to data leakage and exposure. You know, your credit card data, social security numbers, healthcare data can be leaked from the cloud if it is not properly secured and protected. Denial of service, you know, are a huge threat to the availability of data stores within the cloud storage. You know, cloud service store networks that are not resilient may face challenges handling sudden spike in bandwidth. Again, we understand, we all know what is DOS, what is DDoS attack, and that same threat can apply to cloud storage, because cloud storage, the very nature of cloud is ubiquitous, as we studied. And by ubiquitous means that it is present all the time on the internet. And if proper network control, security control measures are not in place, a DDoS attack can bring down a storage device. And what happens if the storage is down? Nobody can access the data. Corruption or loss of data. Corruption or loss of data can affect the integrity and availability of data and may impact specific data in storage or entire storage array. Again, think about the concept of you know, arrays, you know, data mirroring, data duplicating. Those are very important concepts that prevents against data loss, because if one of the physical server hosting part of the data goes down in the cloud environment, there might be a possibility that the rest of data is also become unavailable for anybody to access. So yeah, so threat to storage are both confidentiality, integrity, and availability. Okay. So designing and implementing data security technologies and standards. So since this domain is focused on data security, we looked at what are different storage types, how the data is created. We looked at the various threats to data in the cloud. Now we're going to look at how you can implement security technologies and strategies to improve the security of data in the cloud. What are the various mechanisms that are available at our disposal that we can use to implement data security? So as a cloud architecture, if you are working for a company who is deciding to go into cloud, and obviously they're gonna upload their data into the cloud, you need to understand what technologies should be in place to ensure proper security of the data based on the risk level of that data, based on the business requirement of that organization, based on compliance requirement of that organization. All of these technologies are at your disposal to implement, to understand, to analyze what makes more sense in your specific risk environment, right? You may not be implementing each and every technology on your data, because implementing these technologies is expensive. Expensive in terms of money, and expensive in terms of resources, human resources, and expensive in terms of maintaining. So you have to be very careful in selecting based on your risk profile, your business risk profile, as to what type of technology makes more sense. Some companies, encryption makes more sense. If you want to have hashing just to make sure your integrity is maintained, you need to implement hashing. If you are users who are accessing your data, then you need to implement data loss prevention in case your, maybe example is source code, right? You're a software development company, or you have an in-house development and you write code, which is an IP. And IP, by IP, I mean is intellectual property, not internet protocol. So IP is intellectual property. So you want to protect that intellectual property. So data loss prevention can play a huge role. Yes, DRM is another, and we're going to talk about DRM. DRM is very specific. Generally, we refer to them as IRM, Information Rights Management. Then data de-identification. So data de-identification is by masking and data obfuscation. So you have a social security number, you have a credit card number, you de-identify that data. One example that I can give you data de-identification is in a university, you have a table, you have the name of the student, his date of birth, the courses that he's taking, and then you have name, first name, and last name. Now, the problem with this data set is that you can identify an individual because you have their first name and last name in there. So what is a simplest way to de-identify that data? You can assign a serial number or a roll number in our in our universities and schools. So roll number without the name is a method of de-identification of data, right? Then you have tokenization. So we'll talk about all of these individually in the later slides. Any questions so far? Okay, so you can implement a combination of these technologies and strategies to secure your data. But again, it is very important, and from the examination point of view, is that it's a risk-based decision, right? We are studying everything, but not everything may be applicable in your environment. So you have to make a risk-based decision and select proper technologies that you can justify in your environment and that provide security in your organization. All right, so the first one is encryption and key management. So encryption, as we all know, is scrambling of data so that it becomes unrecognizable. If anybody has an encrypted data, you don't know what that data actually is in clear text format, and you will not be able to see the data in clear text format until or unless you have encryption keys, right? So key is the same concept as your house key. Your house holds your belongings. So that should not be available for anybody else to see, and you have the house key to enter the house, and you can see those belongings because those are your data, because those are your things, and you do not want anybody else to enter your house to invade your privacy, right? So that's the idea. And then to prevent theft, you lock your doors, you lock your windows, and then you have your key to the house with you. Now, what happens if you lost that key, or if that key of your house gets into the wrong hands, or somebody make a duplicate copy of that key? Then what happens? Your house is vulnerable. You are out of the house, somebody have access to the key, they can come back, come to your house in your absence, unlock the door, and now they have access to your personal belongings. You might have personal files in your cabinet in the house, any other valuable. So key management is very, very important when it comes to encryption. So encryption architecture has three basic components. One is the data being secured. In this case, it might be credit card number, health information, social security numbers, your national ID card number. So that's the data that you're trying to protect, or any other intellectual property that company has that it wants to protect. So encryption is the way to go. Then encryption engine that performs all encryption operation. So how are you going to encrypt that sensitive data? So you have to have a certain encryption engine, and those encryption engines use various encryption algorithms. It could be blowfish algorithm, it could be triple DES, algorithm, whatever the encryption type you might be using, or AES-256, AES-250. So these are various encryption algorithms, and all those encryption engines might be using any of these encryption protocols. And then the last one is encryption keys used to secure data. As I gave you the example of the house, that how keys are important. So now, considering these components, you have to establish an encryption strategy on how you're going to encrypt the data. So you can encrypt the data at rest, data in use, and data in transit. So while it would seem like encrypting everything would be the best way to ensure data security, it is important to consider that encryption has a performance impact on the system. So being a security architect, you need to understand, you just cannot go about and encrypt everything, right? Encrypting is costly. It is costly in a way that it impacts performance. It requires more computer and processing power to encrypt and decrypt data. So it will slow down the application, it will slow down the access to the data, and it will have an impact on the functionality. So when you're making decision on encryption, you just don't go and encrypt everything. You take your time, you understand what your data is, and then you select what do you want to encrypt. So system resources are used in order to process encryption every time data is encrypted or decrypted, which can add up if encryption is used excessively. You do not need to cover any details about encryption algorithms. I just gave you that as an example. You are not required to understand any of the encryption algorithms, so do not worry about that. Questions will be based very scenario based. So technical aspects will not be there. So okay, so now we understand in general what encryption is. So how you apply encryption in the cloud and how you do key management in the cloud. So we know that almost all data processing requires that data is in an unencrypted state, right? If data is encrypted, nobody can do anything on encrypted data. You have to decrypt the data to do some sort of processing on it. So data needs to be decrypted before any processing can be done. Second is cloud data is often highly replicated, data dispersion, as we talked about, for availability purpose. So which can make encryption and key management a challenge, because since data is spread across multiple geographical locations, the encryption and key management of encryption can be challenging. Throughout the data lifecycle, data can change states, location, and format, which can require different application of encryption along the way. So again, data encryption it can be for data at rest, stored in archive. Encryption can be for data in transit, for the data that is moving between various nodes. So it depends upon how that data is, which state the data is, encryption application changes. So you have to understand how your data is moving, how your data is storing, where your data is storing. Is it storing in object, is it storing in RDBMS or any other way? So you need to understand how the data is, and the encryption strategy should be accordingly the use of data. The last part over here in consideration is the effectiveness of encryption solution is depending upon how securely the encryption keys are stored and managed. As soon as an encryption key gets into the wrong hand, all data protected with that key is compromised. If you remember, I talked about a solution last time, HashiCorp. So HashiCorp is a key management system, and it is an automated API-based key management system that if you have an application in the cloud, then you have to codify in your application the encryption methodology and the way encryption is going to work. And that will be transparent to user. So application, if user is accessing a sensitive information, for again, credit card information, which is encrypted inside the application, in order for that user to see its credit card information, it has to be decrypted, right? So in the background, the application, the programmer actually code that code in the application, which will call HashiCorp API, provide encryption keys on the fly to HashiCorp, authenticate to HashiCorp encryption key management system, and get the keys, decrypt the data, and show it to the user. And everything is happening in the background. And being a client or being a user of the application, you are not, that whole process is not visible to you. So those key management systems are there. They are being used every day in the cloud when it comes to encryption strategies. Key management, so KMS, or in the exam, you will see this word KMS, key management system. Again, the practical example of key management system is, HashiCorp is a good system for key management. So first one is key generation. So encryption keys should be generated within a trusted, secure cryptographic module. So one of the cryptography module that being used today, which is a standard and which is validated by NIST under FIPS 140-2 compliant algorithms. So those are the cryptographic modules that are certified, that are verified, and it is highly recommended that applications use encryption modules that are FIPS 140-2 compliant. Key distribution. It is important that encryption keys are distributed securely to prevent theft or compromise during transit. So one best practice is to encrypt keys with separate encryption keys while distributing the other parties in PK application, for example. So these two systems, the key management systems, provide all these features that we are studying over here. That they generate the keys. Not only they generate the keys on the fly, they also encrypt those keys, so that when those keys are being transmitted from the store to the application for utilizing to decrypt the data, those keys are also encrypted. So it's a double security that is implemented on the keys to protect the data and protection encryption keys. Because if your encryption key is stolen, then encryption is of no use. Key storage. So encryption keys must be protected at rest when they are stored in a key box or key vault like HashiCorp, both in volatile and persistent memory. And that's where separation of tenants is very important, because as we all know, cloud is a tenant environment. Resources are being shared. So if there is two virtual machines, and for somehow those two virtual machines that belongs to two different clients are sharing the same physical memory or same virtual memory, then there is a chance that a user in one organization and one client environment may be able to access decrypted data from the memory of client B. So you need, so the cloud service providers need to make sure that proper security measures, proper segregation of tenants in place, so that sensitive data cannot be viewed by one tenant or the another. Third one is key destruction or deletion. At the end of encryption key lifecycle, there will be a time that key is no longer needed. So key destruction is a removal of an encryption key from its operational location. So when the key is no longer required, remove it. That's common sense. What happens sometimes, usually when your house gets broken in, what is the first step people do? They change the locks, they change the keys, because your house lock is already compromised, the keys are already compromised, so you have to change them. Or if you have to destroy the old keys. The other aspect of data security, so we talked about encryption as one of the strategy of securing data. So encryption, I think, is a security function that is, no matter what, has to be implemented. So that is a must. That is something we cannot live in today's world. So encryption is a must in a security strategy of data in the cloud. Data loss prevention. So you need to remember one thing: security follows the data. So data loss prevention, also known as data leakage prevention, is the set of technologies and practices used to identify and classify sensitive data while ensuring that sensitive data is not lost or accessed by unauthorized parties. So anybody familiar with any DLP solution that they have implemented in their organization? You might have heard about, give me an example of a DLP solution in the chat. Norton is one solution, yes. Exactly. So these are, I personally have issues with DLP. I do not believe that DLP is a good solution. It is, first of all, it is very taxing on the resources. It is difficult to implement. It is not just a technical solution. You have to do a lot of planning. You have to do data discovery, and the data discovery will happen in structured data storage, unstructured data storage, cloud, object data storage. So there's a lot of planning involved when it comes to data leakage prevention. You have to classify the data, you have to tag the data. So there are a lot of things that happen. It does provide security, it does have its role, but I do not believe it is very effective. And one quick example that I can tell you why it is not effective in an organization, that yes, you identify the data, you classify the data, and then if anybody is trying to leak that data out, it gets detected either through email or through web or copying on a USB stick. However, what prevents anybody to take a picture of a screen with your cell phone? The data gets leaked through that. So there is no prevention from that. So that's where all of your DLP strategy is out the door, because if a user is sitting there, he has access to sensitive information which is being displayed on the screen because he is authorized to view that data, although he cannot send that data out, but he can always take a picture of the screen with his cell phone, and data is stolen. So these are some pitfalls with data, and I had conversation with some of the data DLP companies, and nobody has the answer on how to prevent somebody taking the pictures of the screen. Okay, so DLP implementation consists of 3 core components. I'm not sure how it can be prevented. If you know, do share. DLP implement consists of 3 core components or stages. So first one is discovery and classification. Second one is monitoring, and third one is enforcement. So these are 3 components or strategies when it comes to implementing DLP. So there are 3 DLP data states. So DLP can be for data at rest. For data at rest, the DLP implementation is stored whenever the data is stored, such as workstation, file servers, or some other form of storage system. So in this scenario, what happens is that if you're a user, you're working with IP or other sensitive information, then you have to have a software installed and running on that server or workstation or a file server, that if somebody is trying to copy the data from these endpoints to a USB or a floppy disk or whatever the case may be, or trying to send data out via Gmail or Outlook or other web email, then it gets detected. Second one is DLP in transit, and if somebody is trying to copy data over the network, data loss prevention that involves monitoring outbound traffic near the network parameters. So that is where you put DLP at network level, so which is called DLP in transit. And the last one is DLP in use, which is host-based or endpoint-based DLP, is loss prevention that involves installation of DLP application or workstation or other endpoint devices. So these are the different states of DLP, the way you implement it. I mean, so far, a good strategy that I have seen that worked to an extent is implementing DLP with user-based, user activity-based control software that you implement. So what they do is, it's called UBA, user-based access. And what it does is it develops a pattern of how users are interacting with the network, what are their daily routines on the network. So that UBA or UAB software learns the user behavior analytics, UBA. So it learns the behavior of the user on the network, the UBA softwares, and it establishes pattern over the course of time. So now, if an employee is doing something different, which is outside their normal behavior or normal activity that they do on the network on the daily basis, it generates an alerts and create logs. And in combining UBA software with DLP technology improves the security. So that's a good combination that you can implement in your organization. Okay, other data concepts that we can talk about in terms of cloud are data de-identification or anonymization, masking, and tokenization. So what is data de-identification? So it's the process of removing information that can be used to identify a specific individual from a data set. So this technique is commonly used as privacy measure to protect personally identified information or other sensitive information from being exposed when an entire data set is here. So I gave you earlier an example of student's name and replace that name with roll numbers or any other obscure serial number. So basically you are protecting the private information, and private information in this case is their names, right? So that's what we call data de-identification. So this is one of the techniques that you can implement in on your data when working in the cloud. Masking is the process of partially or completely replacing sensitive data with random characters or other non-sensitive data. I'm sure everybody have experienced this, that when you enter credit card number on the website, most of the time it only shows part of the credit card number, but it X's out the rest of the number. So that's what we call data masking. It basically masks the data so that you do not see the actual data underneath it. Last one is tokenization. So this one is a bit it's confusing. It was confusing to me when I studied for it in CCSP, but I'll try to make it easy. It's an important concept, and it's an important concept in the context of the cloud security, as well as in general on how to implement this technique. And this is an expensive technique. So tokenization is the process of substituting a sensitive piece of data with a non-sensitive replacement, and that non-sensitive replacement is what we called a token. So the token is merely a reference back to sensitive data, but has no meaning or sensitivity on its own. So you need to understand what tokenization is. Again, it's a substitution technique. Tokenization is a data substitution technique, which substitute a sensitive piece of data, maybe a credit card number, with a non-sensitive replacement, which is called a token. The token is merely a reference back to sensitive data, but has no meaning or sensitivity on its own. So if a token is accessed by a hacker, it has no meaning because token has no sensitivity forever. It's basically standing in front of actual sensitive data. So I'll show you how it works. Any question on tokenization? Any confusion on this basic definition? Okay, so let me try to explain tokenization with a figure. So if you look at it on this figure from left to right, so you need to read this figure from left to right. Number one, you have a phone and you download a mobile app payment application and enter your credit card information into it. So that's the first step. You download an application, you create an account, and you enter your credit card information in that application. What happens is that application, if you look up over here, number two, it says the application now is calling back a remote token service server. And it's saying, I have this credit card starting with 411111. So, and it sends that information to token server. Now, token server says, hey, don't use this number, use this token instead. And in three, remote token service server sends a token which starting from 4821 back to the application. Now, this application wants to make a purchase. So that application now go to shop to an online shopping store where a credit card is required for the purchase. So now, instead of the actual credit card number, the token is being given for the purchase in lieu of actual credit card number. So the token number, as you can see, starting from 4281 is being passed over here, 4281. And then through near field communication, or I mean, if you are in store and buying something with your phone and you're paying with your phone, you can process this with, then the question is asked, can you process this 4821, which is the token? The number 7, the merchant or the acquirer getting that credit confirmation goes back to remote token server. And it says, remote token server, is it a valid information? Is this token correspond to this credit card number? Remote token server says, yes, all good. This is the credit card number and this is the token. And that confirmation goes back to the merchant, getting the credit card. And it says token server saying, yes, all good. And then on your phone, number 10, you made this purchase with 411. On this application, on the user, you will see that, hey, yeah, the credit card that you use, which started with 411, is good, and you have the purchase is successful. But you see, between here and here, your credit card information is not going anywhere. It's the token that is being traversing from here all the way to over here. So this way you are basically, so if anything happens in this area, your actual credit card number is not stolen or not compromised. But what instead is compromised is the token number, which is a non-sensitive information. It has no use to the hacker. So any question on tokenization, any confusion on this one? Okay. Let's move forward. Now, somebody asked about DRM. So DRM, again, is a technology that is used by media industry quite a bit to prevent, CDs to be copied, DVDs to be copied, music rights, all those things, they're protected by DRM technology. But if you look at the bigger picture, DRM is what we call is part of overall information right management, because PCI DSS, token is user, any other tokenization is very well part of the PCI process to protect credit card information. And I think PCI DSS documentation has a specific requirement about tokenization of information. And PCI DSS also has a software development guidelines, and that software development guidelines also say to implement tokenization in your application if your application is being used for data processing, credit card information, and all that. Design and implementation, implementing information right management system. So information right management system is a data security technology that protects data, typically files, but also emails, web pages, and other information from unauthorized access by limiting who can view, copy, forward, delete, and otherwise modify information. So what this means, so you're working for an organization. Organization is hosting all of its productivity software in the cloud, and you are generating files for your organization, for your business, using that productivity software. Again, there's no better example than Office 365, right? We use Microsoft Word, we use Microsoft Excel, we use PowerPoint to generate a lot of data, a lot of sensitive information in an organization. So you need to protect that data, because now everybody is mobile, everybody is working remotely, everybody has phones where they are accessing that data. So in my phone, my organization is using MEM, which is Azure Mobile Endpoint Management. And that MEM solution has information right management built into it. I cannot copy or paste any sensitive data if I open any sensitive file on my phone and copy it outside to another application within the phone. So if I open up my personal webmail on my phone, and I also have a document open in my phone, Office phone, and I want to, say, for example, copy some sensitive data from Microsoft Word, which is being managed by my organization, into a web email that I've also opened on my phone, it will not allow me because of information right management that is being implemented via Azure. And if you look at this, let me open up this link really quick. So in Azure, Azure Information Protection is their IRM solution. And this solution provides cloud-based rights management, Active Directory right management, Azure Active Directory right management, and then they have on-prem solution. Other names that they have for this one is MRM, Microsoft Right Management Services, the new Microsoft RMS. So Microsoft keep on changing the names. So these are the solutions that are information right management solution that are available from Microsoft. Any familiar with a PDF files, right? If you open up a PDF file, there's always a security that is part of the PDF file. Let me see if I can open up a PDF file that I can show it to you. Let me open up this file. So this is a file. If I go into this file and I go into properties, if I go into security, you can see that these restrictions, document security, document restriction summary, these all pertain to information right management. So when you create this document, you can specify that if printing is allowed, if document assembly is not allowed, content copying is allowed, content copying for X is allowed, page extraction is not allowed, commenting is allowed. So all of these attributes are for information right management. It allows me what I can do or I cannot do with that document. Okay, any questions on information rights management? Okay. So let me go back. So DRM, which is also part of information right management, is focused on protecting intellectual property through its distribution lifecycle. It's mostly related to media. So now what are the IRM tools properties? So I just showed you an example of Microsoft Right Management. So that is a tool, right? So does that tool comply with these properties? Yes, it does. How? Continuous protection. Continuous protection is a feature of Microsoft Azure Right Management Server. It provides continuous protection. What it means that a key feature of any IRM tool is ensuring that any data being managed by RM and IRM implementation is protected at all times, regardless of its location or data lifecycle phase. So PDF, look at the name, portable document format. What it means is that once you create a PDF file, once you define security on that PDF file, that security is attached to it. And if you copy that PDF file from one computer to another computer or any other storage device, it will keep its protection that is being set on it by the creator of that PDF file. So same goes with Azure. And once you set up those permissions in Azure management interface on how to protect your data, how to protect your files, those restrictions will follow that document. So if I email that document outside my organization to another organization, that information of that document, that security that I have put on that document will follow that document. It will not go away, number one. Number two is automatic expiration. So sometimes you put expiration date on security. So IRM 2 allows an organization to set policies that automatically revoke access to data after a predetermined lifetime. So for example, I want to share a file with my friend and I want to have this control that he can only have access to that file once he have it for 24 hours. After 24 hours, that file will destroy itself or it got expired. So after 24 hours, with the use of IRM technology, I have set up that file to be expired. And once that person, if use that file or do not use that file in 24 hours, right after 24 hours, the file is no longer of his use because the file is expired and he cannot do anything with that file. Dynamic control. So IRM technologies allow organizations to manage access permission even once data has been distributed. So even if the data is being distributed in, by the cloud technology, since that file is generated by the cloud and cloud is ubiquitous, cloud is always present, the file will automatically update permissions because if the file is open, we are connected to the internet, the file going to check for policies from its source and automatically updates permissions and manage access accordingly. It doesn't matter where file exists. Auditability. IRM technologies provide a continuous audit trail of access to data under its control. So again, any file that is being protected by IRM solution is being tracked. Anything happened to the file, somebody adding data, deleting data, accessing data is being logged, is being tracked by the IRM solution. And again, in this case, we are talking about Azure Right Management Server. Integration and support. So IRM tool maintains compatibility with most Office suites and email filtering technologies, allowing regular ground control over not just document and file, but also emails that move through organization. So Microsoft Outlook, Office 365, it follows IRM policies. You set the policies and the filtering technologies and granular controls. If I'm trying to send us sensitive information through the Office 365, IRM will dictate if I'm allowed to send that information or not. It will look for that sensitive information and prevent that sensitive information to go out of the organization. Next topic, any questions so far on IRM? Are we clear? Are we good? Anybody needs any break? Sure. We can take a 10 minutes break. It's 1:50 right now. If you want, and come back in 10 minutes. Is that okay? I don't think so. We have much left though.
I think it's okay to take a break. 5 minutes, maybe 10 minutes, up to you. No worries.
Okay, let's take a break for 10 minutes and then, yeah, 5 minutes is fine. Let's reconvene in 5 minutes. Okay. So the next topic we're going to talk about is planning and implementing data retention, deletion, and archiving policy. So we already talked about these things quite a bit in the previous slide. So a data retention policy is an organization established set of rules around holding on to information. I gave you an example of US government, and under FISMA law, it is required that they keep the data archived or retain the data for last 7 years. Then we have secure data deletion to ensure that no files or pointers to file are left behind after deletion. And we talked about data overwriting, data encryption, degaussing, and physical destruction. So these are various methods of deleting the data or getting rid of the data so that it is not recoverable. And again, these techniques depends upon how sensitive the data, what is the risk profile of the organization. You can use these techniques. I mean, if it's not a high risk data, you can just use data override, but it's a really high risk data where sensitive information, very critical information, then you might want to go to the route of data encryption, encrypt the data and destroy the keys. So that data is just unrecoverable beyond any means. Data archiving procedures and mechanisms. So archiving is a process of removing information from production systems and transferring it to other long-term storage systems. We talked about when we looked at data archival. So basically moving our data from a high-speed tier to a slow-speed tier for storage. Cloud-based data archiving policies and procedures should consider the following topics. And those are format of the data, how the data is being stored. And this is very important because if you're storing data for a longer time, you need to make sure that whatever the application that you are using to back up the data and archiving the data, it has to be in a universal format so that later down the road, that application that reads that particular format is gone, then you are stuck. You cannot read that data, you cannot view that data. So it has to be in a universal format. Business continuity and disaster recovery. So data needs to be archived considering business continuity and disaster recovery. And what are the considerations? The considerations are, data needs to be dispersed. Data needs to be stored in various geographical locations. So if anything happens to the business or to the primary location where the data is stored, you still have data to be accessed from other locations. So continuity and disaster recovery is a critical factor when we are thinking about data archiving. Monitoring and testing of data. So as we all know, when we do backups, we need to make sure the data is healthy. Data is not does not get destroyed. Data does not get corrupted. So you need to constantly monitor that data, and that may include, where the data is stored. Your physical conditions, the temperature control, humidity control, and all those things are maintained where data is stored. Your device where data is being is stored are intact. Tape devices have a lifespan. Hard disk has, they are much more physical devices and can store data more longer. If you store data on a floppy disk, if you know what a floppy disk is, that's a very bad way of storing a data, right? Or a hard disk. Hard disk can go bad. So you need to consider all those parameters based on how long you want to store that data. Protection of data. So by protection of data, again, it means physical protection of the data. Data from, while it is moving from one place to another, data should be encrypted in transmission, in physical disk. So there was a few years back, there was a big data breach that happened for Bank of America. And the way data breach was happening is that they were transferring backup tapes from one location to another location by air. And at the source airport where they were loading the files, somebody stole some of the tapes from the airport while they were transferring those physical tapes. And that's how somebody got a hold of very sensitive data, Bank of America financial data, out of those backup tapes. The only way to protect it at that time is if the data was encrypted, and data was not encrypted on and not protected on backup tapes. And so that can happen. So protection, not only physical sense, but also data needs to be encrypted while being transported in physical format, which is tapes. Restoring that data. Again, if the data is stored in archive, you need to make sure that you are testing that data and it is being restored properly over time. It is a very bad practice that you back up the data and you just leave it for there and nobody's testing, and something happens, now you need that data. A ransomware attack happens and you need your backup data. Now, if you go back to your tape libraries and you try to recover or restore that data, you found out that tapes are corrupt, your data cannot be restored, then you are in a bad shape. So you need to make sure that all these policies and procedures must be taken into consideration when you are doing data archiving. Legal hold. Legal hold is a process of preserving any data that is, will, or may be relevant during a legal investigation. So when there is a legal hold always take precedence over the data retention policy, right? So for example, again, going back to US government example, their policy is that data must be retained for 7 years. Now, if a US government agency is part of a legal process, and legal process takes longer than 7 years, then with that legal hold, even after passing that 7 year, that particular data cannot be deleted by agency because it is part of a legal investigation. So legal hold always take precedence over the data retention policy of any organization. Any questions on this? Okay, moving on. Okay, before we move to the next level, and I know in the last session I got some questions about logging and event monitoring and how logging works in the cloud. But before we go into detail of that, we are pretty much towards the end of our presentation. So the last topic is designing and implementing auditability, traceability, and accountability of data events. But in order to understand that if you can access logs in the cloud, or how much logs you can access in the cloud, or if you cannot even access the logs at all in the cloud, or what kind of data, logging data you can access, you need to understand what type of service you are using. So if you look at this figure that I've put over here, in purple, it is customer responsibility, and in yellow, it is cloud service provider responsibility. And we all know that cloud is a shared responsibility model. So if you look at the very first column on-prem, you see that all of these things is the responsibility of customers. So as it stands in the past or today, if you have your own data center, there is no cloud service provider involved. You're responsible for physical devices, the infrastructure, network, virtualization, guest OS, application, data, and user access and identity. Everything is your responsibility because it's your data center, you own it. So there is no cloud service provider. So that's on-prem. So now move into cloud. So if you are using cloud as infrastructure as a service, then the responsibility gets divided. As you can see, it's pretty much equal in a way that, physical infrastructure, network, and virtualization is cloud service provider responsibility. You don't have to worry about it. And what you need to do is you are installing guest OS, you are installing applications, you are uploading and creating data, managing data, and then also you are managing user access and identity. Moving into PaaS, you can see that now guest OS is also included in the responsibility of CSP, but then as a customer, you're only responsible for application, your data, and user access and identity. Now moving into SaaS, as you can see, CSP has now more responsibility as compared to customer. So physical infrastructure, network, virtualization, guest OS application, these are all CSP applications. The only responsibility you as a customer is for data and user access and identity. So again, tying this thing together, Office 365, if you are using Office 365 services from Microsoft, you're not responsible for physical architecture, infrastructure, network, virtualization, guest OS application. You're responsible for none of that. However, you are responsible for the data that you're putting in, that you're creating, that you're sharing, that you're storing. And then you're also responsible for access and identity management of that data. It's more, so this interrelates with models as well, because models are how it is laid out. And then on those models, you are using that model as what type of services that depends. So it's basically focused on services, not so much on models. So designing and implementing auditability, traceability, and accountability of events. So now we're going to look at, as you can see that we looked at IaaS, PaaS, and SaaS. So in SaaS, which is software as a service, again, think of Office 365. I do not know any other good examples. I keep on using Office 365 just to make a point over here. So Microsoft is not paying me to say that over and over again. So SaaS event source, what security measures should be taken prior to signing an agreement with cloud security provider. And again, that is part of the service level agreement we discussed in last topic. And there are a lot of considerations that we talked about in that. And obviously, depending upon the service that you're using, the biggest one is availability. So 99.9% availability should be there for a cloud service provider and cloud customer. Security. Data is ultimately responsibility of the cloud customer, not the cloud service provider. So vendor lock-in. So those are the things that we covered in session 1. I encourage you to look at session 1, and you will get answers as to what security measures should be taken prior to signing an agreement with cloud security provider. And one of the consideration that we talked about is data security that we are talking about. So data security is, again, another measure and function that needs to be addressed in agreement when signing with the cloud. Yeah, portability is a good thing. Vendor lock-in. So those are the things that we need to consider. So I highly encourage go back and watch session 1 to get these answers. We discussed those in detail. SaaS event sources. In SaaS cloud environment, the cloud service provider is responsible for entire infrastructure, right? So we will not get logs from operating system. We will not get logs from network. We will not get logs from firewalls or other various areas. So in short, in SaaS, anything that is in yellow, we will not be getting any logs from this area. Because we do not have control over here. This is cloud service provider. What we can get is, so this is split in responsibility is great for customers who are mostly hands-off and just want a function application. But remember, it means that these cloud customers have minimal log at their disposal. As you can see from this picture, only logs that a client probably will have is only from these 2 areas. And what those logs might be: admin logs, who is logging into my Office 365 environment, user account logs, and other access logs. I mean, Office 365 is very integrated with Active Directory, right? So those logs you can get. Maybe some application logs, some web server logs, database logs, and billing logs. So the logs that you will get in case of SaaS services are very limited. And client usually select SaaS services because they want to have minimum hands-on. They don't want to deal with all this thing. They have offsource, they have offload this responsibility to cloud. If they need it, they can get it from cloud service provider within the context. PaaS event sources. So organization utilizing a PaaS cloud inherit additional responsibilities over those required SaaS customers, which comes with added access to control over logging and monitoring capabilities. In PaaS environment, the CSP expose some infrastructure level client event sources and diagnostic information. So you can see over here in PaaS, you probably get, as a customer, you probably get more logs from more areas for you to look at. And again, in IS, obviously, the amount of logs you're going to get increased because you have now responsible for more areas. OWASP, if you want to look at, so not even from CCSP perspective, but from general perspective, if you want to look at what should be logged from an application point of view, OWASP has created a cheat sheet that is available for you to look at. And this cheat sheet, you can see it talks about what is the purpose of this cheat sheet, application logging, and what are these logs are valuable for, identifying security events, monitoring policy violation, establishing baseline. And then it talks about designing and implementing and testing, what are the event data sources. So you can look at various data sources that you can collect log from, client software, network firewalls, host intrusion detection system. So these are various areas that you can collect logs from. And this is a very good cheat sheet from OWASP. Where to record event data. Last time, there was a question on if we can integrate SIEM technology with cloud, and yes, you can. And again, depends upon, you can integrate your SIEM with all 3 services, but the level, please include these links in video description. Okay. They're part of the presentation, but if you want, I can share it over here for everybody to have access to. So where to record events. So SIEM is highly integratable with cloud service using CASB solutions. We talked about CASB, Cloud Security Access Broker Systems, in the past. And again, types of the various services. The amount of event logs can vary. For SaaS, it would be minimal. PaaS, it will be a little bit higher than SaaS, and IaaS, it will be more. So you are ingesting more data in case of IaaS, less data in case of PaaS, and further less data in case of SaaS. So, but again, you can get data and you can incorporate that data with your SIEM solutions, which might be your hosting on-prem. And again, I mean, we all know that you do not log everything, because if you're logging everything, then it's just collecting extra data that is costly, because if you're logging everything, you need more storage. And in case of incident, you need to sift through more data and a lot of irrelevant information you might be having. So always identify specific events and, you know, get data for the specific events. Any questions? Event sources. Organizations using infrastructure as a service, cloud models have the greatest access to logs, as we talked about, an event source of any cloud service category. In an IaaS cloud environment, the cloud customer has control and access over the entire environment, which means almost all infrastructure level events and logs are available, as well as platform and application level logs. So IaaS has more logs available at your disposal. So logging, storing, and analyzing data events. So according to NIST, a log management infrastructure includes the hardware, software, network, and media used to generate, transmit, store, analyze, and disposing of log data. So log management infrastructure, and these are the things that, being security professionals, we all are very familiar with. We are just reading them in the context of cloud environment. So log management infrastructure are, you know, log generation. Obviously, you need to generate logs. You need to set up your application infrastructure, firewalls, antivirus system, whatever the case may be, to generate logs. So once the log is generated, you need to analyze and store logs. And SIEM solutions provides you that capability where you are analyzing those logs. And storage, obviously, you need to have. Other frameworks talks about SIEM logging, yes. And log monitoring. Logging is very universal. Whichever framework you pick it up, logging is there. So you need to have logging is a very essential security function. It not only it helps you in troubleshooting if something is gone wrong with your systems or your network, but it also provides, forensics purpose. In case of event happens, then logs provides an in-depth on what happened, and you can reconstruct a story based on the logs. And log monitoring comes in basically, you know, creating dashboards, and somebody is sitting and looking at those dashboards and, you know, creating alerts and, you know, taking action on those alerts. So that's what comes to log monitoring. And SIEM solutions like Splunk or other SIEM, they provide these capabilities into them. The last thing is chain of custody and QRadar. So any log management systems have all these capabilities. It depends upon your personal choice as to what do you want to use based on, you know, your budget and, you know, expertise that you have in-house to use it. A lot of people are try to go to Logstash ELK solution, but it is an expensive solution because it has a learning curve. So although it is free, but it has a learning curve. So people then don't use it. Chain of custody is, again, this is more of a forensics terms. So chain of custody refers to the process of maintaining and documenting the chronological sequence of possession and control of physical of electronic evidence from creation until its final use, often presentation in court. So in case of incidents happens, we talked about forensics, right? A forensic investigator needs to go to on-site or need to go to a cloud customer site to acquire data. So you just cannot show up and get the data. You know, there is a formal process that needs to be followed when you're acquiring data for forensics purposes. And that formal process, chain of custody, is part of that process. And what chain of custody is that, for example, I being a forensics investigator, go on site, I will have a form, and that form has fields to record information as to when I arrived on site, who I met on site, what is the physical location of the server, what is the physical location of the data, who, at what time I started the data acquisition process, who signed off the data handover to me, so that they need to, with sign and date and name, I get the document. So we establish a chain that, the data was acquired and handed over to me, and everybody is involved and everybody signed off. I just did not go in and copy the data without telling anybody. So that's what chain of custody is. So who owns the data? Who is the custodian of the data? Do we record ourselves chain of custody, or it is automatic in the cloud? No, chain of custody is always a manual process because it involves people. So it is not automatic. So it is a very manual process. And in the court, you have to present that chain of custody form. If you Google chain of custody form, you will find many examples of chain of custody forms that you can download and you can use in your organization. Non-repudiation is the ability to ensure that origin or author of data cannot be disputed. Non-repudiation is typically achieved through hashing or digital signatures that provide confidence over data authenticity. So non-repudiation is that if I send you send an email to somebody, later I cannot deny that I sent that email. So the non-repudiation checks needs to be available. Digital signatures is a non-repudiation mechanism. So if I send out an email to somebody else and I digitally sign that email, it basically saying that later on, I cannot deny that I have sent that email because I digitally signed that email and the encryption keys are tied to me. So non-repudiation encryption provides that function of non-repudiation as well. Hashing provides a function of non-repudiation. So for example, you might have download files from internet, right? And usually when you download files, it provides you a SHA hash or MD5 hash. So you can download the file, the hash file is published by the publisher of that software or document on the internet. And then you can, once you download the file, you again run the same hashing algorithm on the file. And if your hash and that hash that is published by the publisher matches, it means that the file is good. So it is authentic. So that's what non-repudiation implies over here. So I think this is what we are end of it. All right, so any questions? I can take questions for the next 7 or 8 minutes if you want to. You can open up the mic, Shazad sir. So this, I mean, we have gone through the whole data security domain in the cloud.
Guys, any questions or should we close the session now?
Rehan bhai, sorry, I have a question. For non-repetition, you mentioned like in the email itself have a like time stamp on it, and probably कोई और इसकी example हो सकती है, like normal documents probably we use, उसमें जब हम updates करते हैं वो non-repetition में आ सकती हैं.
हाँ जी, मैंने आपको बताया ना कि डिजिटल सिग्नेचर जो है वो आप डॉक्यूमेंट्स के ऊपर भी कर सकते हैं, राइट? न सिर्फ ईमेल में भी नहीं, बल्कि कोई भी जो डॉक्यूमेंट है वो भी आप उसको डिजिटली साइन कर सकते हैं. So that's another example of non-repudiation, that whatever the changes that you have made in the document, they are digitally signed by your software, or you have signed it. Right?
Okay.
So that is an example of non-repudiation.
Okay. And chain of custody in cloud. जब हम chain of custody cloud में बात करते हैं, like physically I used it probably 8 years back when like after 2014 they start implementing on specifically for the people who are working outside the America. I saw it like many times. They need that chain of custody with the hard disk. because we were not allowed to format those laptops. अगर वो user जो है वो marked है, but it is like in 2014 onward they started this. In cloud हम chain of custody की बात करते हैं, so that will be a form where we as a customer will be agreed with the service provider, then that will work, or it is something we will only provide, like customer will provide. How it will work?
No,
The
so
chain
for
of
example,
custody.
अगर आपने एक forensics investigator आया आपके पास, right? Event हुआ है,
Okay.
आपका system hack हुआ है, and then you generally you do not do anything after that. You hire a third-party forensics company who comes in and acquire the data, right? So when that third-party company comes in, they will bring that chain of custody form with them, and then they work with you or whoever is authorized to work with them to document everything in that chain of custody form. So you go in, you acquire the data, and then you sign, the forensics investigator acquired the data, and then you sign off on that chain of custody form that yes, the data is acquired, and now I'm giving that custody of data to this forensics investigator. So it establishes a trail, basically. And it is very important to establish that trail, that how the data is acquired, who signed it off, who acquired it, who took it back. Everything needs to be documented to present it in the court of law. Does that answer your question?
I got you, but again, so it is in case of only when we have a breach and we want to do the forensic. Normally, it is not required.
Normally, it is not required, but if a breach happens, if a criminal activity happens where a forensics is called for, and you know, or even in internal organizations when there is an employee who messed up, right? Employee violate a policy, and now you need to do some investigation. Even then, internally, you should have a chain of custody form, because later on, what happens is the employee sues the company, right? It says, okay, this guy is saying not true. Then if the case goes to the court, then you have to have all the documentation. And chain of custody is a very important aspect of it.
I can say like it is also like it can be a company internal policy when a key employee like journal managers, global sales manager, business development manager, they want to format their computers or they are leaving the company, then we should not clean their data. We can have internal procedures, correct?
Right.
And
exactly.
we can tell them like do this guy. One more question. Sorry, if you want to add something on this one, I'm
No,
listening.
I'm good. Go ahead, please.
Okay. For this cloud, when I say like somewhere you mentioned like we can directly access our cloud data without volume. I think so. It was next slide. It is like IP-based access
Yes.
to your SAN. So that is fine. In term of those application, how about the security when it is accessible over the IP? How about the security on that place?
Right. So that's where access control comes in, right? So आप देखेंगे आप अगर आपने कभी अगर OneDrive use की हो या Google Drive use की हो, right? Your data is on the cloud. Data and those cloud servers are accessible on the internet. But other than you, nobody is able to access your data that you have put in the cloud, right? So what do you need to do? You need to provide your username. You need to provide your password. And if you're using a two-factor authentication, you need to do that. And then you are able to access your data. So that access control is what provides the security of the data which is stored in the public cloud. Right? आप अपनी email भी जब access करते हैं, Gmail is in the cloud, right? आप मेरी email नहीं access कर सकते cloud में, although I mean Google is available on the internet, anybody can access it. You know the IP address, or you maybe know the domain name. Everybody goes to gmail.com, right? And everybody gets the gmail.com page, and you have to type in your username and password. And once you provide it, only then you get redirected to your email. You are not redirected to my email, right? So that username and password provides that security.
Only, yeah, okay, I got you. Like it's a make it, yeah, it will make a easy fish. If somebody know the username and password, they can directly go and log in.
Yeah,
Correct.
but it happens, S3 buckets in some in certain cases when S3 bucket is available to internet. And the example that I gave you, that one company, they did not secure their S3 bucket. They did not do secure configuration of that. And what happens is that somebody actually found a hard-coded URL to that S3 bucket, which was holding that sensitive data. And there was no identification and authentication set up on that path, and they were able to download the data, and hence the data breach happened. So these are the
Okay.
cases that happen in the past.
Okay. One more thing. I didn't hear that terminology somewhere. Uh, Somewhere I read about glacier storage. It is like, I think so by AWS. They say it like it's low price storage where you can move your archive data. I'm not
Mm-hmm.
too sure like how many people are using tape storage for archiving their data, because like the place from where I belong, like Saudi Arabia,
Mm-hmm.
people do store the data everywhere, but
Mm-hmm.
99% time what I observe, they don't care about the environment where they save their data, like these tapes. I hardly heard anyone store their tapes in our region, when in the boxes where which are fire protected,
Mm-hmm.
like environmentally protected, like they care about moisture and other environment, and then they move out from the facility. So hardly people get these things to protect their tapes. They always store it in a normal cabinets where it get damaged
Mm-hmm.
easily. And I faced this challenge more than like 50
Yeah.
times in
Mm-hmm.
real time when people ask us, okay, can you restore the data? And then we were like, oh, it's not
Mm-hmm.
working.
Yes.
So
So yeah, these are the considerations, and most often, because having those environments is expensive, right? It's a cost to business.
correct.
And that's why a lot of small businesses do not think about these things. And you, being a security professional, you need to educate them, and you need to identify that this is the risk. So this is something I recommend, talk to the management, present to the management, hey, we are having this issue. How critical this data is to you? I mean, if it is not critical to them, they don't care. If it is a critical data, then obviously they need to take some actions to protect that data.
Okay, there is one next slide to this one. I think so under eyes and pass the second one, volume and objective. Yeah,
This one.
this object means that that's the place which is available through IP based access.
Yes.
That you mean the file
Yeah,
storage?
it's a
Yeah,
file storage.
fine.
It's a flat file structure. It's not like जिस तरह वॉल्यूम होती है, अगर C ड्राइव है, C के अंदर आपके फोल्डर्स बने हुए हैं और उसके अंदर आपकी फाइल्स पड़ी हैं. So that's object storage is not like that. It's just think of it as blocks, right? Or no, blocks is not a bad example. Think of it as a thing which holds data in it, and it does not have a FAT or NTFS partition. Nothing like that. It's just there. And then if you want to access it, you have to have a unique identifier. And when object storage file systems, they do that automatically for you. Whenever you store data in object storing file system, these are all storage systems. They are not tied to any operating system. These are just storage systems. And if application or you want to access that data, the cloud calls that data via API and calls that specific unique ID for that file. It may be a picture, video, or whatever, and it will show you. To you, it looks like just a file on computer, on your web, but in the there's a different type of storage, which is an easier way.
On the next slide, there was two types of more like structured and unstructured.
Right.
So the structured data is whatever like in term of
Databases.
that database. Unstructured,
Yeah.
like what page is it?
Just like a shared drive on your computer. So if you're on a network, right, आपका एक सर्वर है. Simplest example मैं आपको ये देता हूँ कि आपका एक Windows का सर्वर है और आपका एक Windows का वर्कस्टेशन
I
है,
got you.
और आपने Windows के सर्वर के ऊपर एक शेयर क्रिएट किया और उसके ऊपर फाइलें पड़ी हुई हैं, and you're accessing that file. So that's basically an unstructured way of storing the data.
I got it. I got it. I got it. I got it.
Okay.
I'm good.
Okay. So
So
what
should we
trust
close
issues-
now? Or do
Okay.
anything else?
There's a question that says what trust issues are involved for data collection from CSP. I'm not sure what about this question. अगर आप माइक पे आके बात कर लें तो easy हो जाएगा ना समझने में. सैयद अहमद अली साहब.
सईद अहमद अली, आप अपने आप को अनम्यूट करके बात कर लें.
हेलो रेहान भाई, मेरी आवाज आ रही है?
जी आ रही है.
हाँ रेहान भाई, एक्चुअली लिटरेचर में कुछ यूं है कि ट्रस्ट इश्यूज इन्वॉल्व होते हैं डेटा को कलेक्ट करने के लिए सीएसपी से. यानी इसकी कुछ पॉसिबिलिटीज ऐसी हैं कि सीएसपी जो है वो किसी क्रिमिनल से मिलकर जो है डेटा को मॉडिफाई कर सकता है बिफोर प्रोवाइडिंग द डेटा टू द इन्वेस्टिगेटर.
नहीं, ऐसा पॉसिबल नहीं है क्योंकि जब you go to a cloud service provider, you define all those terms and conditions in SLA, service level agreement.
सही है.
Right? And if they are if they're not following those things, then they are liable. Then you can take them to court. आप उनके साथ जो भी कानूनी तौर पे आप चाराजोई कर सकते हैं उसके ऊपर.
Okay, thank you Ranveer.
No problem.
Okay, sir, I will close the session. Thank you. Okay.
Thank you, Rehan bhai. Thanks, everyone.
Thank you. Okay.